Welcome. Today, we're diving into service-oriented software engineering. We're going to explore how building software has changed in a really big way, moving from creating these huge single programs to instead assembling applications from smaller, independent building blocks. Think about how a skyscraper gets built. Nobody shows up on day one and starts melting iron ore to make beams, right? Instead, they assemble standardized, pre-made components, windows, girders, electrical systems. Well, modern software development works a lot like that. We're getting away from building one gigantic, monolithic application. Instead, we're putting together smaller, independent, reusable parts called services that talk to each other over a network. So in this chapter, we're going to explore that exact evolution. We'll look at how we went from the old days of clunky, rigid connections between programs to today's super flexible world, a world built on standardized services that can be found and used by any application anywhere. It's a really fundamental change in how we think about software engineering. All right, so here's our roadmap. First, we'll nail down what a service actually is. Then we'll look at two big blueprints for using them: the very formal approach called SOA, and its more lightweight cousin, REST. After that, we'll get practical and walk through how you'd engineer a service. And finally, we'll see how all these pieces get put together to build really powerful applications. Okay, let's start at the beginning. What is a service, really? And why did we even need this new way of getting software to talk in the first place? So here's the formal definition. A web service is a loosely coupled, reusable software component. Now, reusable is pretty straightforward. You can use it over and over. But the key phrase here is loosely coupled. All that means is that the service is independent, it's self-contained. It doesn't really care about the internal details of the app that's using it, and the app doesn't need to know how the service works inside. It's like a black box that just offers its features over the internet. And this idea is what really separates a modern service from an older software component. Think of an old component as a custom gear in a car's engine. It's tightly coupled. It's designed to work only with the other specific parts around it. A web service, on the other hand, is like a USB port or a wall outlet. It's loosely coupled. It just provides power. It doesn't care if you plug in a phone charger or a lamp, and your lamp doesn't need to know anything about the power grid. That's the whole idea. A perfect everyday example is the info system in your car. The software in the dashboard doesn't actually know how to predict the weather or translate languages. It can't do that. Instead, it just acts like a manager. It sends out a request to a weather service, a translation service, a traffic service, and then it just collects the answers and presents them to you on the screen. The real power isn't in the car's software itself, but in its ability to combine these other services. So building things this way has some huge advantages. You can mix and match services from different companies to get the best of everything. You can also wait until the last possible second to decide which service to use. That's a cool concept called late binding. Think about an e-commerce site choosing the cheapest shipping service in real time. You can also build brand new services just by stringing together existing ones. And of course, you pay for what you use, and you can let a powerful server in the cloud do the heavy lifting for your phone. So if this is such a great way to build things, how do we first get started? Well, the first major blueprint was a very formal, very structured approach called service-oriented architecture, or SOA for short. The SOA world really revolves around three main players. You've got the service provider, that's who builds and runs the service. You've got the service requester, that's the application that needs to use the service. And right in the middle, you have this thing called the service registry. The easiest way to think of the registry is like a phone book or a directory just for web services. And this setup leads to a really clear three-step dance. First, the provider publishes a detailed description of its service in that phone book, the registry. Then, the application that needs help, the requester, finds that description by looking it up. And finally, the requester uses that info to bind or connect directly to the service and start using it. Publish, find, bind. It's a very formal, deliberate process. Now, what makes SOA so formal and powerful is that it runs on a whole stack of strict standards, often called the WS star stack. The big ones you'll hear about are SOAP for formatting messages and WSDL. You should think of WSDL as a very strict, legally binding contract. It spells out everything about the service, exactly what it can do, what the messages must look like, and its exact address. This level of detail makes SOA really good for big, complex business systems where you can't leave anything to chance. But all that formality, all those rules, it kind of makes you wonder, right? It's great when you need that kind of control, but what if you don't? What if you just want a much simpler, more lightweight way for two systems to have a quick chat? And that question leads us directly to the RESTful alternative, which, as you'll see, is all about having that simpler conversation. The big idea with REST is a total change in perspective. Instead of focusing on actions, we focus on things, or resources. In the world of REST, everything is a resource. Your user profile, that's a resource. A product in a catalog, that's a resource. And the key thing is, every single resource gets its own unique address on the web, its URL. Now here's the beautiful part. REST doesn't invent a bunch of new, complicated rules. It just uses the simple verbs that already run the entire web. The 4 basic things you'd ever want to do with data: create, read, update, and delete, map directly to the HTTP verbs you already know: post, get, put, and delete. It's so elegant. You want to read something? You just get its URL. Simple as that. And because of this, the requests themselves are often so simple a human can read them. I mean, just look at this URL. It's not some cryptic code. It tells you exactly what it's doing. We're getting temperatures for Edinburgh on a specific date. The entire question is just right there in the address. The URL itself becomes the command. So if we put them side by side, the difference is pretty clear. SOA with SOAP and WSDL is like that formal legal contract. It's heavyweight and very specific. REST is more like a quick, informal conversation. It often uses simpler data formats like JSON and just piggybacks on the basic rules of the web. And another key idea with REST is that it's stateless, meaning every request has to contain all the info the server needs. The server doesn't have to remember anything about you from one request to the next. Okay, so we've got the 2 big architectural styles down. Now let's switch gears from theory to practice. How do you actually build one of these services from scratch? Well, the process usually breaks down into 3 main stages. The first is identification. You look at your business and try to find functions that are used all over the place. For instance, validating a credit card is a perfect candidate for a service. Next up is design. This is where you map out the public face of your service. What functions will it offer? What information does it need to do its job? And what will it give back? And finally, you get to implementation and deployment, where you write the code, test it, and put it on a server for the world to use. And this brings us to the grand finale, the most powerful concept of all. Once you have a bunch of these services, these individual building blocks, how do you snap them together to build something much bigger? The answer is you build workflows. This is a classic example. Let's say a travel agency wants to offer a complete vacation package. They don't have to build a system that does everything. Instead, they can create a workflow. The workflow's first step is to call a book flight service. Once that succeeds, it calls a book hotel service. After that, an arrange car service. See? Each step is just a call to a separate, independent service, and the workflow acts like a conductor, orchestrating the whole thing.
Now, these workflows aren't just doodles on a whiteboard. They're actually mapped out using a formal standard like BPMN. That's Business Process Modeling Notation. It's a universal visual language. The rectangles are activities, like calling a service. The diamonds are decision points, like is the hotel available? And the circles are start and end points. Using a formal blueprint like this lets engineers design, test, and even automate these incredibly complex service combinations.
And that leaves us with a pretty big question to think about. As these services become the standard Lego blocks of our digital world, is the very job of a software engineer changing? Are we moving away from a world where we spend all our time programming things from the ground up and moving towards a future where our main job is to compose applications by cleverly orchestrating these powerful pre-built services? That shift from programming to composing is really the heart of service-oriented engineering, and it's changing everything.